Imagine a storm that has been raging for 350 years. A single cyclone so large it could swallow Earth. But giant storms are only the beginning. Earth has continents. Mars has deserts. The Moon has craters. Jupiter offers none of them. No solid surface at all. Descend beneath its clouds, and the journey downward may never truly end. A world so immense that it nearly became a star. A world unlike anything else in the solar system. So what exactly lies beneath those clouds? What exactly lies below? We tend to imagine planets as places with a sky above and solid ground below. A surface marks the point where an atmosphere ends and the planet itself begins. On Earth, that boundary is obvious, but on Jupiter, there may be no clear dividing line at all. From a distance, Jupiter appears as a world hidden beneath swirling clouds. But a probe descending into those clouds would never hit solid ground. Instead, its surroundings would gradually become denser, hotter, and darker. Layer after layer, the atmosphere would simply continue downward. Descending into Jupiter would be less like approaching land and more like diving into an endless ocean. And yet, the journey inward begins long before the deepest layers. It begins in the clouds. The colorful bands are not markings on a surface. They are immense gas rivers encircling the entire planet, flowing in opposite directions. Jupiter rotates in less than 10 hours, more than twice as fast as Earth despite its enormous size. That rapid spin drives powerful jet streams and creates storms on a scale unlike anything seen on our planet. The most famous is the Great Red Spot. Larger than Earth itself, this enormous storm contains winds exceeding 400 miles per hour. While the most powerful hurricanes on Earth survive for days or weeks, the Great Red Spot has been raging for at least 190 years, and perhaps for centuries. Yet even this giant storm is changing. Over time, it has become smaller, taller, and more intensely colored. Data from Juno revealed that it extends hundreds of miles beneath the visible clouds. But scientists still do not know why it survives for so long or what gives it its reddish hue. The clouds themselves form distinct layers. High in the atmosphere, ammonia freezes into countless tiny ice crystals. These crystals scatter sunlight so efficiently that they create brilliant white clouds, tracing out the broad, pale zones visible even through small telescopes. But those bright clouds are only the highest layer. As we descend deeper, the atmosphere becomes warmer. Here lies a region rich in ammonium hydrosulfide. When sunlight strikes these compounds, it triggers chemical reactions that produce many of the orange, brown, and reddish colors that paint Jupiter's darker belts. Still deeper lie clouds of water ice and liquid water droplets. They likely possess a bluish hue. Together, these immense cloud layers create one of the most recognizable faces in the solar system. A world whose colors are painted by chemistry itself. For decades, scientists thought they understood Jupiter's atmosphere. Then one spacecraft descended into the clouds and discovered something that made no sense. In 1995, we looked inside its atmosphere for the first time. A tiny robotic probe dove into Jupiter's thick clouds, beaming back groundbreaking data for almost an hour. Scientists were absolutely certain that massive reserves of water were hiding just beneath those upper clouds. But the probe sent back something bizarre. The area it flew through was completely dry. This cosmic mystery challenged researchers for over a quarter of a century. The answer was finally uncovered by a modern, high-tech spacecraft named Juno.
Escape pod away. Cruise shuttle B5C08. Repeat. Shuttle has ejected escape pod.
It turns out, Jupiter's water didn't just vanish. It's constantly moving in the most mind-bending way possible. Let's figure out how this strange weather works. High above the clouds, water mixes with another gas, ammonia. Normally, in this extreme cold, water would instantly freeze solid, but the ammonia stops it from freezing completely. Instead of hard ice, it creates strange, soft, slushy hailstones. Scientists actually call them mush balls. These heavy, wet mush balls are constantly plunging deep into the planet. As they sink, they drag almost all the water from the upper atmosphere down with them. It turns out, that original probe back in 1995 just happened to fall right into a massive, invisible desert inside Jupiter. A region where these falling mush balls had already sucked out all the moisture. It's an extreme weather system unlike anything we have here on Earth. But what happens to those mush balls as they keep falling? The deeper you go into Jupiter, the more extreme the heat and pressure become. Eventually, the planet's gas atmosphere gets squeezed so hard that it transforms into something entirely different, a mysterious, alien state of matter, completely unlike the gas we know. Pressure rises, temperatures climb ever higher. Hydrogen and helium atoms are forced closer together by a weight unlike anything found on Earth. Near the upper layers, these elements behave as ordinary gases. But farther down, something remarkable begins to happen. There is no sharp boundary. Instead, the familiar distinction between gas and liquid slowly begins to disappear. Under ordinary conditions, temperatures of thousands of degrees would turn hydrogen into a violently expanding gas. But inside Jupiter, the crushing pressure becomes so immense that the atoms simply cannot spread apart. Imagine trying to inflate a balloon while millions of invisible hands squeeze it from every direction. No matter how much air you pump inside, the balloon cannot expand. Something similar happens deep inside Jupiter. Heat pushes outward, but pressure pushes back, and pressure wins. And so, despite temperatures hot enough to melt rock, hydrogen remains compressed into a dense fluid. An immense ocean of liquid hydrogen fills much of Jupiter's interior. In fact, Jupiter contains more liquid hydrogen than anywhere else in the solar system. Even after 4.5 billion years, the giant planet still radiates nearly twice as much energy as it receives from the Sun. Somewhere beneath the clouds, a hidden source of heat is still at work. And strangely enough, the explanation begins with something that sounds almost impossible. The answer begins with rain. Deeper within this vast ocean, something unexpected begins to happen. Like oil separating from water, helium slowly separates from the surrounding hydrogen. Gravity pulls this strange rain deeper into the planet. As it sinks through the darkness, colossal amounts of heat are released. For billions of years, this hidden rainstorm has helped fuel the giant planet from within. But helium rain is only part of the story. Under the immense pressures deep inside Jupiter, hydrogen itself transforms into an exotic liquid known as metallic hydrogen. In this strange state, electricity can flow through the fluid. As vast currents of it slowly move through the planet, they generate the strongest magnetic field of any planet in the solar system. That field extends far beyond Jupiter itself, forming an enormous invisible bubble known as the magnetosphere. Near the poles, this powerful magnetic environment creates colossal auroras hundreds of times more powerful than those on Earth, shining not only in visible light, but also in ultraviolet and X-rays. Yet even this extraordinary world hidden beneath the clouds is not the end of our journey. Because far beneath the metallic hydrogen lies the most mysterious region of all, its core. For decades, scientists imagined Jupiter's center as a giant version of Earth, a dense sphere of rock and metal. But when the Juno spacecraft began studying the planet's gravity, it revealed something unexpected. Instead of finding a compact core, scientists discovered that the material deep inside Jupiter appears to spread outward, blurring the line between the core and the layers above it. No clear boundary, no obvious place where the core truly begins or ends. Scientists call this strange structure a fuzzy core, and exactly how it formed remains one of Jupiter's greatest mysteries. One leading theory points to an ancient catastrophe. Billions of years ago, a young Jupiter may have collided with another growing world. That violent impact could have disrupted the planet's original core, mixing its material throughout the deep interior. But whatever happened in the early days of the solar system, Jupiter's center remains elusive. No human eye has ever seen these hidden depths. Everything we know comes from subtle clues hidden in gravity and magnetic fields. And perhaps, even at its very heart, Jupiter still has stories left to tell.